Let's look at another problem that deals with radicals. So here we're talking about the area of an equilateral triangle is given by the formula A is equal to the square root of 3 divided by 4 times s squared. Find the length of the side s of an equilateral triangle with an area of square root of 12 square inches and round to 3 decimal places. So the first thing, let's think about this. Equilateral triangle, remember from geometry, means we have 3 equal sides. So each side is s. In fact, they tell us side s. So s means side. Okay? They give us the formula for area. So area is the square root of 3 divided by 4 times the side squared. So what have they given us? They want us to find the length of the side. So we don't know what s is. Of an equilateral triangle with an area of the square root of 12 inches squared. So that means the area is the square root of 12 and we have square inches. Okay, so what do we have? We have our area, which simply gets substituted in for our A. So that means A is the square root of 12 inches squared, which is the square root of 3 divided by 4 times s squared. So we want to solve for s, which means we want to get this by itself. Well, what's happening between the square root of 3 divided by 4 and the s squared? Well, those are being multiplied, which means we have to unmultiply this. Now, traditionally, students want to take that and divide by the square root of 3 over 4, but that's really cumbersome and you can get confused. So it's better to take the reciprocal and multiply, which is what would happen if you were to divide anyways. So what I do to one side, I have to do to the other. Now remember, the square root of 12 is in the numerator, so I'm going to put a 1 there just to remind myself of that. I'm going to erase this here also. Okay, so this all divides out to 1. So now I'm left with 4 square root of 12 over the square root of 3, and I'm just bringing my units along for fun, equals my side squared. Okay, so we all know in order to get my side, my s by itself, I'm going to have to take the square root to get rid of that. But before I do that, let's clean this up. So this is the same as 4 times the square root of 12 over the square root of 3. So because these are both the same radical, this is the same as 4 times the square root of 12 divided by 3, which is the same as 4 times the square root of, well, 12 divided by 3 is 4. And so if I do the square root of 4, the square root of 4 is 2. So then that gives me 8 inches squared is equal to the side squared. So now, as I was saying before, I have to take the square root of both sides. I'm not going to do plus or minus because I'm talking about distance, and distance is always positive. So I'm going to move this up over here because I've kind of run out of room. So I'm just going to rewrite that. Square root of 8 inches squared, which by the way that should be under the radical also, is equal to the side. So when I look at this, square root of 8, I'm going to do the same thing with my units. Inches squared equals sides. I have to rationalize this. So my perfect square, that's a factor, is 4. And then 4 times 2 gives me 8. Well, if I take the square root of a square, it undoes it. So I'm just left with inches. And that equals my side. So this is the same as the square root of 4 times the square root of 2 inches. Square root of 4 is 2. Square root of 2 is the square root of 2. So each side is 2 square root of 2 inches long. And that's my final answer.